Hello, Algebra 1 class. Mr. Martin here. Welcome to this week's installment on systems of equations. That's what we're going to be working on. We worked on it last week. We're going to take a little look at it again this week, where we're kind of deciding between elimination and substitution, what to use when we're given a system of equations. We're going to be recalling on a lot of what you learned previous weeks to kind of solve the systems. So before we get there, a few things. Today's Tuesday. We did not have any class yesterday, or we didn't have any work to do yesterday because it's a holiday. Tomorrow's Wednesday. I'm just going to ask that we have a packet work to do. Kind of take what we're doing here and show me that you can do it by putting in the packet and then submitting it to me. You can either do that through Canvas, you can do it through my email, and then on Thursday is a catch-up day, so you can kind of make up work that you have missed over the past weeks if you are all caught up. There's also extra work in some of the packets that you can continue to work on. Friday is our social emotional day, where you can meet with Miss Armisen and Miss Johnson a couple times a day. They do a Google Hangout, and Mr. Nelson, Mr. Bergenholtz also do a Google Hangout a couple times a day on Fridays. Join them, say hi to them. They would love to see your faces. Okay, we do miss you guys a lot. We spend a lot of time with you during the school year, so it's difficult for us to kind of be away from working directly with you. I hope everything's going well with everyone. I hope everyone's getting the material, and if you're not, please reach out. And after the video, just so I know that you watched it, take a second, give me a little comment on the video, send me a little email, let me know that you watched it. That way I can mark you down for it. So let's take a look at what we have here. My learning objectives. Students will be able to determine between using substitution and elimination when solving systems of equations. Now, when do I use them? We know we went over them last week. We solved systems using elimination. We solved them using substitution. When do I use them? Use elimination when there is a way to eliminate a variable by adding the two equations together. All right, your x variables stack up over each other. You have a positive 2x and a negative 2x. You add those together, it gives you 0. All right, you get rid of that x variable, and then you have that y to solve for. Substitution, when a variable is equal to an expression. So y equals 15 plus 9x would be a way that the variable is equal to the rest of the expression. All right. So let's take a look over here, what I have on the board. I have x equals 3y and 2x plus 7y equals 26. Is there anything that eliminate if I stack them? No, they don't stack well. Okay, I have my x value is just x in this one, and a 2x down here, a 3y and a 7y. Those don't work out to eliminate anything. But I do have a variable equal to an expression. So y or x is equal to 3y. So I can take this 3y right here and plug it in to anywhere that I see an x. So I'm going to rewrite this equation. 2 times 3y instead of x. I plug that 3y in for x. 3y plus 7y equals 26. 2 times 3y is 6y plus 7y equals 26. 6 plus 7y is 13. Y equals 26. Divide by 13. Divide by 13. Y is equal to 2. Okay? It's my y value. Don't forget, we got to plug it back in. Find my x value. So x is equal to 3 times y. And we know my y value is 2. So x is equal to 6. So 6, 2 is my answer here. Okay? Easy enough. I decided I was going to use substitution. I used my substitution method, found my x variable, found my y variable, and then I wrote it in ordered pair term. My x term first, and then my y term second. Great. Let's take a look at one. It's a little bit different. All right, we have 4x plus 2y equals 18, and then 12x minus 2y equals 46. All right. So I take a look. First thing, elimination. Is there a way to get rid of an x variable or a y variable right off the bat? I say, actually, if I put a line here, my x, or my y variables, I have a 2y and a negative 2y. They cancel each other out if I add those together. So I'm left with 16x equals, so 18 plus 46 is going to be 64. And then divided by 16, divided by 16, 64 divided by 16 is going to be x is equal to 4. All right. So I know what my x is equal to. Then I got to plug that x back into one of the equations. I'm just going to plug it into the first equation because that seems like the simplest way to do. And so we have 4 times my x variable, which is 4, plus 2y equals 18. 16 plus 2y equals 18. Subtract 16. Subtract 16. That's 2. So we're left with 2y is equal to 2. Divide by 2. Divide by 2. Y is equal to 1. So my x is 4. So I have 4, 1. That's 4. Those are my answers, okay? My x is 4, my y is 1. I used elimination to solve, and then I plugged my variable that I found back into the equation. Easy enough. Now, let's try one more system that's maybe not right off the bat, you don't quite know what to use because it's a little different. But we'll take a look at it and we'll see if we can figure something out. Okay, so we have 4x equals 3y minus 22. 4x equals 3y minus 22. And then my second equation is x plus 3y equals 32. X plus 3y equals 32. Okay, so I take a look at this and I say, is there any way to just eliminate a variable? Well, they don't quite stack right now. I have my x on one side and my y and my constant on the other, and then I have an x and a y and a constant on the other. The equations don't stack up, so I don't quite know. But what about substitution? Is there a variable equal to the expression? There's a variable, but it's not equal to the expression. I could change that around. I don't know. It doesn't seem easy to set anything up right now. I don't know how to use it. I don't know which one to use. Do I use elimination? Do I use substitution? So we'll take a look. What are my x variables? I have a 4x and then an x. Okay. And then I have a 3y and a 3y. Wait a second. So I do have two 3y's here. If one of them was negative, we'd be able to eliminate, and that would then I'd be able to manage. So what if I brought this 3y over to the other side of the equation, where my x and my y stack up on the same side of the equation? Let's see what that looks like. So all I'm going to do is I'm going to subtract 3y from this side of the equation, so minus 3y, and that's going to cancel here, and I'm going to add, it's going to end up being subtract 3y from the other side. Because when I do the one side of the equation, I got to do the other. And my new equation is 4x I'm still going to have, minus 3y equals negative 22. Now I can see here that my 3y and my negative 3y are stacked up, and I can go ahead and cancel them. Then I'm left with 5x equals 32 minus 22, 10. Divide by 5, divide by 5, x is equal to 2. Great. Now let's plug it back in. Let's find my last piece here. I'm going to plug it into the bottom equation over here. So I have x, which is 2 plus 3y is equal to 32. All right. So I want to get rid of the 2. Subtract 2. Subtract 2. 3y is equal to 30. Divide by 3. Divide by 3. Y equals 10. 2. 10 is my answer. Okay? So, the only difference is I couldn't figure out a great solution right off the bat, but once I rearranged the equations and I used what I know to kind of put my x's and y's on one side of the equation, I saw it actually did stack up. You had opposite numbers, you had opposite variables, and you were able to then eliminate. And once you eliminate, you solve and you finish it off. All right. So hopefully this helped. Hopefully things are going all right with this virtual learning stuff. I know it's very difficult. It's a lot. There's a lot of distractions at a lot of your houses. A lot of distractions here at my house. I to kick my children and my wife outside to do this. So and they're good sports about it. So I know that there's a lot going on and it's very difficult at times. If you need anything, please reach out. We're here for you. We're here to help you. Okay. Thank you. And I look forward to your comments.